So in number 7, they're asking for the equation of a line that does two things. First, it needs to be parallel to this line. And then the second thing it needs to do is it needs to pass or own this x and this y value. It's got to go through this point. So if our red line was like this, all right, our blue line has to be parallel to it, okay? And it's also got to pass through this point negative 5, comma 2. So right now, as I've sketched it out, this line doesn't work because even though it's parallel, it doesn't pass through that point. I've got to make it pass through that point. And when we do that, that would change the y-intercept, also known as the b value. Because if I don't make that line go through that point, right? Let's pretend that point is still over here. Then that y-intercept is going to be different. So when I force it through that point, it makes a different y-intercept. And that's kind of the trick of this problem. It's figuring out, well, okay, well, the slope's easy. I'm just going to have the same slope from the original, but I don't know what that y-intercept is. And you're going to use this point to help you figure out what the y-intercept is. So let's actually go ahead and solve this. We're going to write out our equation, 4x plus 3y equals 7, and we're going to solve for y. So I'm going to subtract 4x from both sides. I'm going to get 3y equals minus 4x plus 7. Divide everything by 3. And I know this looks strange, but honestly, I don't care about the y-intercept. All I'm interested in is the slope. Yeah, the equation is minus 4/3 x and 7/3, but like I said, that y-intercept does not matter to me. The only thing I'm interested in is the parallel slope will be equal to the original slope of minus 4/3. So our new slope is still going to be minus 4/3. And we're going to put a little placeholder here for the parallel y-intercept, and I'm going to write out my equation now. I'm going to write out the y equals mx plus b, and I'm going to substitute what I know. I know my y value is 2, so that will go in for the y. I know my slope, my m value is minus 4/3. I know my x value is minus 5, and I'm going to toss it over 1, just so I can do the multiplication easier. And that, when I simplify this and solve for b, will tell me my y-intercept. So there's nothing to do to the 2. Numerator times numerator is positive 20, and denominator times denominator is positive 3. I got a y-intercept over here, and I'm just going to subtract this thing from both sides. Whatever I do to one side, minus 20/3, I got to do the other. So if you didn't like that, me subtracting by that fraction, I would encourage you to convert this problem into a decimal. 20 divided by 3, so that's 6666 repeating, and that is what's getting subtracted from 2. So we're going to get that minus 4.66666 and so on. And if I needed to, I can convert that to a fraction, and it's negative 14/3. And I could also do that here. So I know my y-intercept is minus 14/3. And if I needed to convert that to, I'll leave it as 2. 2 is really equal to, I'm going to put this over 1. I can multiply this by 3/3. Right, 3/3 is 1. 3 divided by 3 is 1. So if I multiply something by 3/3, I'm in other words, multiplying by 1, and I'm not changing its value, I'm just changing what it looks like. And I'm playing a trick here. So 3 times 2 is 6, and 3 times 3 is 3. So when I go to do this subtraction, when I go to do 2 minus 20/3, 2 is really 6/3. And I'm doing that so I can actually do this subtraction with 20 over 3. Because you're only allowed to subtract things when they have a common denominator. So when you subtract, you keep the denominator, and then you just do the operation to the numerator. So 6 take away 20. 6 take away 20 is where we're going to get that minus 14. That's how I know my y-intercept will be minus 14 over 3. So when I go to write out my new equation, that's the information I'm going to use. Y equals my slope of minus 4 thirds times x. And I'm going to tack on that minus 14 over 3 as my y-intercept. If you're a little skeptical about this, that's a-okay. We have GeoGebra, luckily, and we can try it out that way. So let me open up GeoGebra. Let me open up that problem again, and we'll graph that 4x plus 3y equals 7. 4x plus 3y equals 7. Boom. I'm going to turn on my axes here so we can kind of orient ourselves. And what did it want me to do? That's right. It wanted me to graph this point, negative 5.2, minus 5, comma 2. The parentheses around there. And it wanted me to make a parallel line. So parallel line. And there's my equation. I'm going to turn it into y equals form. And you can see, hey, my slope is, let's get this down to look over here. My slope is at minus 1.33. And I can just show you that minus 4 over 3, minus 4 divided by 3. That's the slope, minus 1.333, and so on. And that minus 4.67 is really minus 14 thirds. Minus 14 divided by 3, the minus 4.666, and it's just repeating and terminating at the 7 there. So math is a beautiful thing. If you do it correct, follow all the rules, you'll never be wrong. Even how absurd and crazy this equation looks, that's just how it works. That's what it needs to be in order to satisfy these conditions. I'll see you in the next one.